Hi everyone, welcome to the regression analysis lecture. For this session, we're still working on the variable selection. We've discussed this before, backward elimination, forward selection, and stepwise procedure. We've discussed about that. And now we are at the all possible regression selection procedure. There are four common methods that are usually used in selecting the models. R squared, adjusted R squared, and CP criterion. We've discussed them all in other videos. For this session, we will be discussing about the price criterion. Okay, and subjectively speaking, I am very recommending. I mean that among these four criterion, I think that the price criterion is kind of like just relatively good ones compared to the others. Why is it? Because we can see here from the formulation here, okay, the R squared or adjusted R squared or the CP criterion from the previous videos, they all just calculated, you have the model, you fit your model to the data, and then you calculate these criteria from the resulting fitted model using all the data that you have. So it's kind of like a bit cheating, I mean that the one that you use to calculate is the one that you build using that exactly the same data so then in that case you already know the pattern. Okay, it means that we want to get a good model, that is a model that is strong enough, robust enough, consistent enough when it has to do prediction or insight on new data, right? So that's what the price criterion doing here. Okay, so what does this formula mean? So this one we have here with the what is it? With the bracket. So yi minus yi cap and I in the bracket for the second one. It means that we have a sample size of n, and then we have our model here, and then the yi cap means the predicted y, but because the I here is in the bracket, it means that the predicted value from the data that is not used in the model building. Okay, uh, so what does it mean? Actually, here let's say you have like n sample, guess a sample of size n, then for I equals 1, for example, then you build your model using data, using observation number 2, 3, 4, all the way to observation n. Okay, so the first observation is not included in fitting the model. And then once your model is fit to the data, you get your parameter estimation. Then you use the parameters to do the prediction, and then you do prediction for the first data that you just excluded when you're building the model. And then for I equals 2, you redo the same thing. Okay, so then you fit the model using n minus 1 data points, taking out the second data, you get your parameter estimation, and then you predict the second data points using that result. So in total, if you have n data points, you will need to do n times regression, which seems tedious, right? But I think that's fair enough, right? No pain, no gain. Here, by having something like this, your model is kind of like really, what is it? Tested to the relatively new data compared to the other three criteria that's still working on the data that's used to build the model. Okay, so we'll just see the what is it illustration of doing it. Here I already do provide some codes. Let's say we just I just generated, I want to generate like sample of size 10. Okay, so just 10 observations. And then this is my x1, the first explanatory variable. I generated from a uniform distribution with the value ranging from 10 to 20. If you want to know, that's our x1. And then so x2 here also take a value from 1 to 19, and if you want to know, there's our x2 in here. And then this is how we generate the y. So construct it from x1 and x2 and put some noise in here. Okay, and then the price before, as I told you, if we have 10 data points, it means that to calculate the price for this model, then we have to run 10, what is it, regression fit. So how to do that? So if I want to calculate, for example, for I equals 1, I want to calculate y1 minus y1 cap, where the cap here is with the I in the bracket. So it means that I have to do it using, okay, I just take it from here. Okay, so I will just create another data set. Let's say, okay, I just put the data in, okay, x1, x2, this is the whole data set. And then to calculate that y, so now I want to calculate y1, okay, y1 minus y1 head of y1, where the 1 here in the bracket, okay. So how to do that? So then we fit a regression using the sample number 2 to number 10. Okay, so in that case, here I will just do it in here. Let's see, I put okay. So I just create new data set, that is I name it DF, and what does it looks like, so it's just a sample consisting 9 points, okay, so excluding the first one. And then I will just feed a regression for this. So then y blah blah blah, here I do something like this. I put dots, that means take all the variables in the data set of df, okay, with y as the response, means that taking x1 and x2, okay. And then if we want to look at the result, then here we go. So as you can see here, CF statistics on 2 and 6 degrees of freedom. 6 is from 9 minus 3, because we have 3 parameters here to be estimated. Okay, so this is the result. What I really want to get is that, to calculate the y cap from this result for my first data point. Okay, if you want to remember here, this one. And then according to that result here, so if we want to do the calculation, that is, so my y cap should be 64.451 minus 3.208 times x1 for the first data point, 14,19556, and then minus 1.968 times the second data point is 9, x1, I mean x2 for the first data point is 981292. So this is actually our y1 cap, okay. And if you want to know the value, so this is the predicted y1, okay. And then the actual value is that minus 14.5 43597, and this is our predicted value. Okay, but we don't really need to do that manual calculation. We can just do something like this. So I can just create, okay, new data. This is I create new data set that is the initial data set excluding including just the first data point that we didn't use in what is it fitting the model, and then we can just using this code to do the prediction. Okay, so do the prediction based on the model that you fit before, apply it to this new data set. So if we want to get the value of I cap, that's the value that we have here. That's kind of like, similar, yeah. It's slightly different, but it's just for the rounding errors. Okay, so the same with that one. Okay, so that's how we get the y. I had this how we get this yi in the bracket cap, okay, for the first data point. And then for I equals 2, then you have to do it again. You take out the second data, for example here. Okay, I just do this. Okay, from the initial data point, you exclude the second data. So then you fit your model using data 1, 3, 4, all the way to the 10. And then you fit it. And then, you create the new data that you will be predicting that one. And then you do this. And then you get that, what is it? You get your predicted value. Okay, here that is your predicted one, while the actual value is this one. Okay, you see that it's kind of like, the predicted and the actual value are kind of like very different, but I think this just makes sense because, we have that only 10 data points, and then, I put the noise here is kind of like, the data is very scattered actually. If you want to see the plot of x1 and y, see, and then plot of x2 and y, yeah, very scattered. And also the sample size is too small because just want to illustrate how it works for the breast. So instead of doing it one by one, we can just kind of like create some codes in here. So then put like a loop. Okay, so for I in 1 to n, and then we create our data set to be fitted for the model. Take out the if data, and then you feed your regression, and then you create the new data for you to do your prediction, and then you calculate the residual because we need the residual, the square of the residual in here, yi minus yi cap squared. So we just do the calculation there. Okay, and then after that, okay, so you have that one, and then if you want to look at the for this, then for those 10 data points that we have it, and then for the press is just the sum of those square of the residual. Okay, so this is the value of the press, and then so you can just decide when you have to do your model selection, then which model should I choose, then just choose the model with the smaller press value. Thank you.